This video is an overview of the ground station and how the software looks and functions. Here you can see the two input devices, two 360 controllers, keyboard, mouse, and then the two monitors. And we'll switch to a screen recording here. To launch the software, you open a terminal and type roslaunch rover_main ground_station.launch, or hit up and hit enter on the most recently used one. When you launch it, it's going to start all the ROS nodes needed to connect to the rover and handle topic transports so that the ground station can send and receive information, and then it'll launch the GUI itself. Once it's loaded, you'll see the maps in the center there is still loading, and it has a little loading icon in the corner. Up in the top left here, you have all the system statuses. Rover connected doesn't work. FR Sky connected does, and then the two 3D nav mouse and Logitech ones do not do anything. The entire next row, which is all radio information, all works and is actively querying the Ubiquiti radios for it. The next line is all GPS information. The only one that isn't valid is GPS heading valid. And then the next line is a bunch of generic computer information such as CPU percentage and RAM usage. The next row, battery voltage is correct, and then the whole bogey or the wheel groups are ready to accept the information from the bogies, but they haven't actually been connected. CO2 levels works, and then everything on the bottom row except for the Z connected works. Then down here, we're going to take a look at the radio direction finding tab. This entire area is a tabbed group for all the miscellaneous functions of the rover. The raw data readout here is essentially the raw analog output from the Teensy on the radio, getting averaged over, I think, a window of 100. It's a rolling average. And the bottom there, we get a readout for the FFT of that data to give us the most common frequency. This should bounce around when the data is flowing normally. And then once it's stabilized and it's gotten a frequency that's relatively stable, frequency valid will turn green and say yes. And you'll know that this is actually valid. At competition, we were finding a signal that was exactly a hertz, and it was 1 hertz pretty much bang on, like maybe 0.999, but very, very accurate. Over here on the ARM tab, you can see there are a couple grayed out icons here. These are actually disabled in the code, and I have some comments about it. These will allow you to stow and unstow the arm, but due to the fact that the wrist pitch broke, we couldn't use them, so I disabled them so I couldn't accidentally hit it. Upright 0 does what you think it does. Moves it all to the 0 positions for the axes, and then you have a bunch of task movements on the right here for doing things like approaching the O2 tank. There are also these special functions such as setting the calibration, where you set all the arm joints to their 0 positions, hit it, and then it zeroes out the axes at that point. You can also use the clear faults and reset motor drivers function to get the arm out of strange fault states. Most of the time clear faults works, but in worst case conditions the reset motor driver button will take care of some other issues. You have to be really careful with the movement commands on this page. If the arm isn't calibrated, or if you are not paying attention to where the arm is when you hit the button, it is a sequence of commands for the most part, so it'll move to like a known location before continuing the sequence, but if you hit it at the wrong time, it is possible to move the arm into something you really don't want it to hit. There's also gripper controls. There's a home button. This opens the fingers all the way up into their homing sequence. Sometimes you have to do it more than once. There's also a toggle light button to enable and disable the light on the end of the gripper. Over here is the map. You have zoom and pan capabilities. It is very, very glitchy and jerky. This has to do with the way that the mapping system was written. I'm sorry, I didn't end up writing that one, so I didn't have any control over it. But it is functional, just very slow and glitchy. Be slow and careful with it. Click and drag to pan, scrolling for zoom. And you just have to be careful with it. Up in the left-hand corner, you get the live readout of the latitude and longitude of the rover from the GPS. And then the heading shown on that map is equivalent to the heading that you see down here on the compass, although the next goal reading is the same. Down in the waypoint entry and editing, you can adjust colors for waypoints. You can add waypoints by the GPS location. You can update colors for GPS locations. And then right now the navigation waypoints aren't doing anything, but in theory they would be used for the autonomy. So you could set a series of waypoints, enable autonomy, and then it would try to follow them. We never got that far as autonomy never was working. And you can delete waypoints. Pretty common waypoint features for the map. And that autonomy section doesn't do anything at all. It's just a placeholder. Let's see, over here on the mining tab, you can see we have a readout for the measurement from the scale on the rover. We also have the readouts for the lift and tilt positions of the mining system when it's attached, as well as some preset movement positions for mining and science operations. Don't mix these up, otherwise you might break something. Especially when you have the science end effectors on, you could move the probe into something and just snap it in half. There's also science probe data down there. Temperatures, salinity, all the useful information that they want. It's also important to note that when you're using the mining system, you can actually control the axes directly with the controller. Use the Xbox button to switch it into mining mode, and then you'll be able to move it. Let's see, down here at the very bottom you have camera controls for the point and shoot camera on the end of the mining system. An important note is that the network and LCD buttons change where the video is getting output, so you won't see any video on the end effector view in the GUI if you don't hit the network button, but when setting up the camera it's useful to use the LCD on the camera itself, so you can hit LCD to swap it there for whoever's setting it up. Then you have common commands like zoom in, zoom out, full zoom in, full zoom out, and a shoot button to actually take the picture and store it on the camera's SD card. There's also a 0 button for mining if there's any noise. On the SSH console window, you have the ability to type in normal command line commands. This is essentially just a not very nice SSH interface. It does work, but typing in commands there is not necessarily the right way to do it. Use the buttons when possible. But these are all the useful commands for talking to equipment servicing. One thing that will need to be added later is a username and password box. Did not realize it was going to be needed, but it is very useful for quickly seeing what Wi-Fi networks are nearby, and then using this interface to actually connect the rover to the equipment, and then using the buttons to just quickly log in, to log out, to query its status, and get all the information that you need for the competition. For this year, you only had to log in and show the status. In future years, they might actually make us use the interface, so this already has a lot set up in order to be able to do that. Also, the host for this year was 192.168.0.1. In this case, I have it set to the default testing server that the competition set up. Over here on the settings tab, you have the ability to change the maps. There's a particular file that lets you set which maps are allowed to be shown and which ones are cached and all that kind of information. You also have zoom levels. These zoom levels correspond to the Google zoom level numbering system, which is a little confusing, but you can play around with it and get an idea of how it works. There's also a Ubiquiti radio channel set button. This isn't needed for CIRC, but if you're at URC, you'll need to use this to set it to the channel that the judges request at competition time. So this is a one-click button that just sets it and you're done. You can see here when you change maps, it takes a little while to switch over, so that's just the nature of how the loading system works. And there you go. Okay, over on this monitor, we have the arm joint readouts. These 6 are in revolutions. They all have limits that are both soft limited in my code and also limited on the motor controllers themselves. So, for example, the base is plus minus half a rev. And this is information that comes back pretty fast, so you can use it to get a pretty good sense of what the arm is doing. You also have the gripper joint and currents for all of the motors inside of the gripper. The positions are kind of arbitrary. You'll have to get a feel for what they actually mean. It's mainly for a sanity check. And then the currents are the ones that are important. They're again kind of arbitrary values, but if you see something, over like 30, 40, you know that the motor is stalled and you probably want to remove power from it. Really, a stalled current is probably going to be more like 90 to 150, but just something to pay attention to. Down below, you have the ARM motor driver statuses. These give you full readouts for the states of every motor controller inside the ARM, whether there are any faults, and then gives you an idea of what you need to do to clear them. It also tells you things like whether or not the motor drivers are actively moving in axis. Really just a lot of useful information to have at quick glance, just to do a sanity check, make sure things are working right. Again, you can use that clear faults button to clear them when they have errors. Down here you have the reported mode and set point. These come back from the gripper. It was again another sanity check thing while we were doing debugging. It shows us what mode the gripper thinks it's in. Right now the software is actually limiting it to pinch only, but this tells us what the gripper thinks it's in, and then a reported set point, which is the value I send it from 0 to 65,535. It's what the gripper says, hey, I have this number, and is sending back. Again, mainly just used for debugging. See, down here we have the headings readouts. This is accurate, although it's important to note that the rover must be started pointing true north right now, because I couldn't get absolute positioning working. That was an issue with the IMU that I haven't been able to solve. And then the next goal is also just showing the same direction as the heading currently. The rover speed limit is the maximum limit for what full forward on the rover's controller sticks are, and then the ARM speed limit limits the max speed of the ARM while you're moving it. These are both very useful when driving the rover and needing to do fine motions where you don't want to accidentally break something. There's also readouts down here for the pitch and roll coming back from the IMU. If I shake the tower here, you'll see the numbers jiggle a little bit. Also the raw tank drive output going to the motors. When you enable the controller, the readouts there will go from red to a live view of what the output power is. But yeah, so there's a lot of information here on the GUI. There's a lot to be added, but overall I think it's done a pretty good job of what it needs to do. But ultimately it's stable and has pretty much all the readouts it needs to. So with that, I'm now going to shut off the rover. Now, when you want to shut down, you can either shut off the rover or the ground station first, it doesn't matter. But you click anywhere on the GUI and then hit Control Q to actually click back to the desktop. It should exit cleanly, and then you're done.